Hello everyone, I'm Paul and today we're solving problem 2411, smallest subarrays with maximum bitwise OR. This is medium and here I will show you how to solve this efficiently. We are given an integer array nums and our job is here. We need to return an array of the same size where each element in this array is the length of the minimum size subarray starting at that element with maximum bitwise OR. Let's see what this means. Let's say this is nums, and in case you don't know what a subarray is, it's a contiguous sequence of elements. So for example, this is a subarray, this is also a subarray, but we can't form a subarray with 3 and 2 because these elements are not contiguous. Now, in case you don't know what bitwise OR is, here we have these numbers. This is the base 10 representation of each of these numbers. And this is the corresponding base 2 representation of these numbers, meaning this is binary. Now let's say we are trying to get the bitwise OR value among 1 and 2. So we are comparing each position from right to left, and we are checking the following. If we have at least 1, 1, the resulting value for this position is 1. And if we don't have at least 1, 1, the resulting value is 0. Here we have 1 and 0, so the resulting value is 1. Here we have 0 and 1, so the resulting value is also 1. So the result of 1 bitwise OR 2 is this in binary, which is 3 in base 10. For example, if we do 3 bitwise OR 1, here we have 2 1s, so the resulting value here is 1. And here we have at least 1 1, so the resulting value is also 1. So 3 bitwise OR 1 is this in binary, which is 3 in base 10. Now going back to the problem, the key to solve this is bit masking. And this is how this works. We will have a mask with enough bits for every number in this array. Here we have the constraints. We know that every value in nums can be smaller or equal to 10 to the power of 9, so we will have 32 bits for this mask. So let's say we have our mask with 32 bits and we are only looking at the last 2 bits right now, and we will start every bit with a 0. And we are iterating this from right to left from the last index, so the I pointer is here initially. And each time we want to check which are the bits that are 1 in this number. Here we have the binary representation of 2. And we want to take each of these bits that are 1 and replace this with the corresponding value for the current position. Here we have the indices. This is index 0, 1 and 2. So now our mask will be 2, 0. Because remember, this bit is 1, so we are replacing this 1 with the current position. And the result at this index, remember this is index 0, index 1, index 2. We are standing in the last index. So the result here will be the maximum value in the mask, meaning 2, minus the current position, meaning 2, plus 1. This is 1. So the result for this position is 1. Now the I pointer is here and we are doing the same. This is the binary representation of 1, and given that we have a 1 here, the current state of our mask is 2, because this is 0, we keep this 2 as it is, and we replace this with the current position, meaning 1. And now for the resulting value in this position, we take the maximum in the mask, meaning 2, and we do 2 minus the current position, and we need to add 1. The result for this is 2, so we put a 2 here. And what this means is the following. We need to take the length of the minimum size subarray at this index with the maximum bitwise OR. The maximum bitwise OR among these three elements is 3, because if we do 3 or 1, the result here is 1, 1, and if we do this or 2, the result is also 1, 1, and this is 3 in base 10. So the maximum bitwise OR that we can get in the entire array is 3. So from here, the smallest array with the maximum bitwise OR, meaning 3 or less, is this, 1 and 2. This has a length of 2, and that's what this 2 represents. When we were here, the maximum bitwise OR that we could get at this point was 2, and this array has a size of 1. That's why we have a 1 here. So now the I pointer is here, and we could take this subarray, and the bitwise OR for this entire subarray is still 3. But remember, we need to return the length for the minimum sized subarray. So now we are doing the same here. This is the base 2 representation of this, and we are checking which bits are 1 here, and we are replacing these bits with the current position in the mask. So now the mask is 0, 0. So we can add to the result the maximum value among these, meaning 0, minus the current position, 0, plus 1. This is 1, so we put a 1 here. And what this 1 represents is that the minimum size subarray that we can take with the maximum bitwise OR, meaning 3 or less, at this index is this subarray. So next we update the I pointer, we reach the end, and we return the result, which is this. So this might seem complex at first, but I think once you get the idea for bit masking, and you know what bitwise OR is, and of course you need to know what a subarray is, I think this becomes easier. So time and space complexity for this will be big O of n. And now let's go with the code, and hopefully you will get the idea. First we say n is length of nums, and we will call our mask last. So this is an array with 0 times 32, and the result is an array with 0 times n. And now we are iterating every element in reverse. So for I in range n minus 1 up to minus 1 in steps of minus 1. Now we say for every bit in range 32, if nums I bitwise and 1 left shift bit. So what this means is for every bit that's 1 in the current element, we say our mask, meaning last, at the current bit is equal to the current position, meaning I. And now we say result at I is the maximum in our mask, meaning last, minus the current position, I, plus 1. And finally we return the result. Now it might be a case in which the first element in the array is 0, meaning the rightmost element in nums is 0. And in that case, when we get the result for that element and we get the maximum value in the mask, this will be 0, because this will be false. And this is wrong. This is a wrong result. The minimum subarray with the maximum bitwise OR has to be at least 1. So here we will say the result for each element is the maximum among 1 and this. So now this is it for the code. Let's submit this and see if it works. This works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.